Hello everyone, welcome back to the channel. So today is our part 7 of Gen AI learning series, and we'll be talking about building LLM application. We'll be talking about the foundation of building out any LLM application. Then we'll be talking about RAG, retrieval augmentation generation, and then we'll be talking about how to create or build agents using QAI, AutoGen, and then we'll talk about the MCP protocol. So that we are going to cover in next two to three videos. And just to recap, like what we did in last couple of videos is we learned about the transformers, which is the fundamental architecture of any Gen AI. And we talked about the encoder decoders and BERT model. And specifically in last video, we talked about how image generation model evolved from GANs to stable diffusion and then DITs into the multimodals. And today we'll be focusing more on building out the LLM application, and we'll start with the first topic of prompt engineering. So when we say like large language model is a powerful engine, then prompt is highly calibrated wheel. And our goal is to learn how to turn that wheel into with the precision, and especially as we leverage the power of platform like any inference model, then how we are going to write a efficient or effective prompts. So our goal is to master the prompt engineering. So what exactly is prompt engineering is the craft of designing and defining inputs are our prompts to effectively guide the LLM to generate the desired output. I'm sure like you all must be know like about what is prompt and how the prompts are used, but after this session you will be having a altogether different perspective of prompts, and then you will be thinking about actually like how the LLMs process or takes the input as prompt and then how like it generates the data. So just be with me, and we'll be learning the different prompt techniques which will enable you to make your LLMs to provide the output to respond in a better way. So as we know that prompt is nothing but input text to our LLM, and the output is generated. That could be like a summary of text or whatever creative content you want to write with your LLM. So that is basically the output. So how effective or accurate this output would be is actually rely on this prompt. So that's why like this prompt engineering is a crucial thing to build out your LLM applications. So the core concept or the core component of any prompt message is system versus this user messages. These are two critical parts, and we should understand very much clearly like how these two messages are different and how these are crucial to any input which you are providing. So system message actually defines the rule or the expected behavior of your LLM, like how you want your LLM to respond to generate the data is actually system message. So you can actually define all the rules, what should be included or what should be excluded from the output. So you can basically say like as an example, you are an expert financial analyst where you can answer the questions in bullet points. So you are defining the rules for this LLM, and that could be application, any agent application or any application which uses LLM as part of like its core engine. So just think about ChatGPT, like we cannot see any system message of the ChatGPT, but what we provide is user message. So when we interact with the ChatGPT, we provide our query to ChatGPT, and that is the user message. So when I say like, okay, give me general weather of Paris in January and February, so that's my user message. But the system message is kind of like pretty much hidden with ChatGPT because it's an application, and as we are talking about building out our own application, then this system message again like plays a very critical and crucial part for it. So I'll show you like what I mean by system message, and you may be like having a vague idea also like what system message would be. So the best practice is to keep the critical behavior rules in the system message and keep the immediate task and data in the user message. So that's the primary rule to follow when you want to build out your any application. So these are two critical parts, and if I move to this next part, that is hyperparameters, which we call in normal term as temperature. So when we say like temperature low 0 to 0.3, then it's sort of deterministic model, like where you want your model to predict based on the top defined keywords. So when you say like 0.03 or low value, then it would be less creative. It will be like predicting this with the help of same predictable tokens, and the predictions would be nearly always same. Used for the problems of classification and the extraction, where we just want to classify based on positive, negative, or yes or no, or do some extraction or specific summarization of the data, then we keep the temperature low so that our model or our LLM should not get into the vague answers. And then when we keep the temperature as high, then it's more creative. We are giving the full flexibility or full liberty to our model to go for the different answers. So again, this is one of the parameter, and once we get into the code, we'll able to see like what we mean by this temperature. And then we have like multiple prompting techniques, and as we talk about these prompt techniques, so we'll be taking example of this code as well. So I will show you the code. So if you are watching my previous videos, then you know like we use this Google Colab, so which is a free online platform by Google that lets us to write and run the Python code into our browser itself. And along with that, we are going to use the inference of this Groq Cloud. So you can log into this console.groq.com, where we would be having multiple free LLMs that we are going to use to make any API calls. We can use the API calls from OpenAI, but because these are paid ones, so if you have already a paid account with them with having the credit, then you can use this OpenAI keys to make any API calls. But if you don't, then I will suggest you to have this Groq Cloud, so that we can use all the freely available models. So we'll mostly work with this free one. That's a model, open source model from OpenAI, that is GPT OSS 120B. And we have multiple others, like based on your choice you can pick, but this quite a decent model with 120 billion parameters. So we'll use this one, and it's free. So we can make our applications to use this inference model. And we are not going to use OpenAI that because it's a paid one. And if you have Google AI account, then you can use the Google AI API calls also. Like you can log into AI Studio and get your API key and then make the same sort of calls. So for our demos, we are going to use this free Groq Cloud. I'm just closing the other ones. And now we'll be talking about the prompt techniques. There are multiple prompt techniques, and we'll be learning them, and as well as we are trying them into our code at the same time. So foundational technique is zero shot. When we say like it's just providing your questions in normal English and then expect the LLM from its trained data to answer your query. So we are not providing any additional data, any additional stuff to your LLM. So it could be like simple question of like what is the weather in Paris in January and February. So you can ask this like based on pre-trained data, LLM would try to answer it. That's a simple way of like asking question without giving any additional context to LLM. So it's a zero shot prompt, and you are relying on model's inherent knowledge entirely. So when I go to my code, and I'll show you this one, and as I said, like we'll be using this Groq inference models. So we need to install the library that so that we can use the Groq. That's why I have done this pip install Groq, and you can run it, and then we'll import the Groq library from Groq, and then we'll be importing this Google Colab user data because we have provided our Groq API into secrets of Google Colab. So you can actually create a new secret, so you can add new secret, and once you have the API, then just give it a name, Groq API or whatever you wish to give, and just place your this key over here. Then it's ready to be used into your Colab environment. So once we have this key ready, then we can import the Google Colab user data, and then we'll read the Groq API key from here. So it's as simple as we are just having the secrets or the API key into this Colab secret so that we can readily access it. So you can hardcode, you can pass this as hardcode string also, that's not a problem, but just for the security. So we are just using that from Google Colab user data. And over here, then we are defining our LLM model. So as I said, like we are going to use this OpenAI open source model that is 120 billion parameter one. So we'll use it. So you can install this one, just install the Groq libraries. And once you have this, then you can run this import OS, import Groq, import random at time. These are inbuilt libraries which I'm importing just to have everything in place one shot. Now comes to our example of zero shot prompting. So over here, just look at this part. So we have this text input that is user message. So this new Groq inference speeds are phenomenal and exceed all expectations. So this is the user input. And then we are calling one function. And if you have already watched my video about this Python basic, then you know this is a function which starts with def. So zero shot prompting is my function name. We are passing our input as a parameter to this function. And over here, we are writing our system message. So you can see like we have this, you are an expert in sentiment classifier. You must classify the sentiment as positive, negative, or neutral. Provide only classification words. So this is a system message. We are giving the instruction to our application that what we are expecting. And user message is the query of the user. And this is this client.chat.completion is a standard method of within Groq Cloud function, where we can just create this message, provide the system role, and the content for system role is system this message, and then role is user role, and then content is user message. So these are pretty standard way of like passing the parameters to our chat completion function. And then we pass this model name, and model name is we have already defined as OpenAI 30B model. And over here the temperature is 0.0 because we are expecting a deterministic answer as positive, negative, or neutral. So if we give this as a high value, then the response would be a bit vague because we are allowing our model to be very creative about the answers. So for any classification problem, we generally keep this as a low value, and that's what we are doing over here. So in zero shot, we are just giving one question and expecting the answer based on the trained inherited knowledge of our LLM. So when I run this cell and the input which has passed this, and zero shot result is positive. So that's how this zero shot prompting is generally works. So whenever you interact with ChatGPT, if I open ChatGPT and I try to say that, okay, show me your system message, and the response I get said, I can't show you my actual system message because it's confidential, right? So all the applications keep their system message, their rules, constraint, and everything as in secret. They don't, reveal it. But what I can do is like I can ask simple questions. What is 4 minus 2? So with the LLM, its own trained data, it will answer like this. So that's sort of zero prompt engineering where like we are just passing our question and expecting the answer. Going back to our slide. So that was first, and then we have this foundational technique that is few shot, where we are providing some examples to our model, and based on our examples, the model judges like what we are expecting. So for example, server down in main data center is critical type of incident. Minor UI bug on login page, it could be a low impact. And target input, what we are, this is our user message, network congestion causing intermittent system lag. So it could be our system user message where we want to pass that to our LLM, and as an output for the classification, we are giving few examples to our LLM so that they can decide the criticality of that incident. So we provide a list of examples with prompt with the output also, so that LLM can help to decide, and it has the more context about our questions. So when we go to our code, and I will just go to the cell where we have written this few shot example. So over here you can see like I have this system message. Again, the same way we have in the zero shot, you are an ID expert and risk classifier. Your response must strictly follow the format demonstrated in the example. So this is our system message, and few shot prompt, we are providing all our examples. So over here you can see like we have this triple double quotes. So that's a format for a long or lengthy string in Python. So we are giving this one formatted string example. We are providing, okay, this server down is critical one, UI minor issue, and the target, the system, the user message, we are going to pass this target for the classification. So this target issue is our user message, which we are going to pass. And in this one, like in the chat completion function, we are passing system role, user role, LLM model, and still the problem is this deterministic. So we are just keeping the temperature as low. And once we provide our user message and run this one, then we get our this, okay, network congestion causing intermittent system lag is an high impact incident. So that's how like these few shot prompt engineering works. Like you provide the examples for your questions and then let your LLM decides the answer or the output for you. And then we come to the next one, that is chain of thought prompt, and it's a bit like more advanced than the zero shot and the few shot prompts. So what it does is like it actually makes your LLM to think step by step before reaching to any conclusive answer. So the example is, I have 12 pens, my friend gave me 5 more, I lost 3, and how many pens I left with. So with chain of thought, what is like, it provides a logical reasoning behind every step that LLM is doing, and then based on this multiple steps breaking down, it reaches to the final conclusive answer. So I can again circle back to the code so that we can take a look in real time how what it means is. So chain of thought is again like can be of two types, that is chain of thought zero shot and chain of thought with few shots where you provide the example. So we just take a look on the zero shot one. So over here In the system message, we are providing this, you are a logical problem solver, show all the steps and end with the final answer. This is a system message, as we are expecting to break down all the analysis in steps. And then we provide our this user message that I started with 12 pens, my friend gave me 5 more, I lost 3 pens, how many pens do I have? So over here in this one, you can see like I have provided this user COT message also. Let's think step by step so that it can give the logical reasoning behind each and every step what LLM is doing. So if I just run this one, so the question, the problem statement which we gave to it is I started with 12 pens, my friends gave me 5 more, and then step by step calculation. So it's initializing the pens, then pen received, pens lost, and everything will be shown into all analysis into detailed steps. So that's how this chain of thought works, where each step actually contains the proper reasoning for any reaching to any conclusion. And the fourth one, which is actually quite interesting and very important also, is this self-consistency prompting. So what that means is like when we ask when we pass the user message, question is always a user message, then the LLM provides multiple responses into multiple iterations, and then those responses are evaluated with the scores, with the defined scores. So all the answers for different reasoning paths should be matched, and the majority one wins. So consider this like you are asking same questions to 5 professors, and if majority of professors are giving the same answer, then that would be considered as the final answer. So the LLM takes the different reasoning paths, and here we provide the temperature as high because we want LLM to provide the multiple different creative answers, and the multiple answers based on the majority would be considered as winning, and the final answer will win. So we can just take a look on this part. So in the self consistency, like we are just first of all we are just defining this method that is runs self consistency, and we are taking this prompt is user message, just a question, and then n sample. So over here we are going to do 5 different paths. We want our LLM to create the 5 different responses. So we are saying n samples. Temperature we are passing as high, that is 0.7, and in system message we are saying you are an expert problem solver, you think step by step and explicitly state the final answer at the end of your response. And the important part over here is like you see like we have this range of n samples, that's 5. So we are doing the same generation of answer, the chat completion, for the 5 time, where we are providing system role and user role again at the same time, and over here passing the model temperature is high, and every time we are going to expect a different answer. So once we have this different answers, we are just appending answers to the answers list, answers array, and then we are just calling one more method that extract final answer. So if I scroll up, we have one more method that is extract final answer. So because in our system message we provided that append this final answer into the answer, so that's why like we are able to just say like if our text is containing final answer, then we'll be extracting the final answer, then splitting and stripping off this other part, and then join the final answer and then show that as output of final answer. So what over here we are doing, we are generating 5 different responses, and then 5 different responses, multiple responses is having the same answer, same output, then we are considering that as a winning answer, and then we consider that as the output of our LLM. If I run this, and for the same question where we are passing a project requires 10 workers for 5 days, and we only have 4 workers, how many days it will take, assuming all workers work at the same pace. So what it is doing is like it's calling that for 5 times or 7 sample, because over here we are providing this samples as 7, so it's giving the 7 different answers with the 7 different ways of thinking. And then finally, because all these paths are leading to the same conclusion, that the work would be completed in 12.5 days, so that would be our majority answer. So right now, because it's a pretty much a mathematical question, so that's why like we are getting a very definitive answer. So if it's a not a mathematical questions or not it could be a like a generic answer. So what is the weather in Delhi like all over the year? So sometimes we'll get the Delhi is warmer, Delhi's winters are very cold and all that. If we do 10 iterations of it, and if we get the answer that is what is the weather of Delhi generally in January to April, then final answer would be like it's sort of winters in Delhi like in that duration. So that's how this self-consistency prompt works. And then we have this final one, that is tree of thoughts. So it's also like pretty interesting, and it's used for very complex, answering very complex scenarios or problems, especially like in gaming, like to find the multiple routes to reach to the destination. So over here, like if we put up the question that is a user message, plan a marketing campaign for a new project, let's say, and then it will try to create a root node, and then all the root nodes would have their own plans, the sub plans, the proposals, and then it will be evaluated as well at the same time, and some would be discarded as like not a valid output, and some would be considered as a valid output. So final one would be the final plan, which would be given, are the which are falling not in the discarded plan. So discarded plans like would be just go off from the table, only the final plan would be showed up as an output. So when we say like, okay, give me a travel itinerary for 5 days for Italy, where like in winters I want to visit Italy, then I would be getting multiple proposals would be created. So maybe like I may be interested in historical places, maybe interested in modern places, or some nightlife like I would be interested in. Then multiple branches would be created. And if, because my question is like I will want to visit in winter, so probably like this wildlife safari and all that would not be a good idea in winter, so that would be discarded, and only itinerary would be considered the remaining planning part. So we can take an example of this type of TRIOT prompt engineering also, like so initial plan, I'm describing that as a plan a detailed 3-day 3-city European itinerary focused on history for a budget of 500 per day. So over here, this is my user message, and the important parts are like I'm focusing on 3 cities and my budget is also this one per day. So the LLM should be more focused on like on these criterias. It will be creating branches based on these criteria. That one of the branch could be like luxury hotel, so that would be discarded because I am providing my budget as 500 per day. So in the final answers, that luxury part would be discarded because it's not what I expect. Now we are creating proposed thoughts, one function. So that would have our this system message that you are a strategic planner, give the initial problem, generate exactly k distinct high level next steps. Each thought must be concise and actionable. And user message is my problem statement which I am passing, and then progress so far, steps completed, because I would be interested in like just seeing the path where it's going just for our demo purpose, like how our tree is built, and generate the k candidates next steps thoughts. And then we are just calling our this chat completion function. We are passing the system and user message. Again, for multiple paths, we want to keep the temperature as high. And this is the raw output. First execution would give us raw output, that is proposals would be generated initially by LLM. Then those proposals would be evaluated against the same LLM, where again we'll define one system message, that is you are an evaluator, access the provided path against the initial problem. So initial problem was like 3 cities, historical visits, plus the budget constraint. So it will be evaluated against those user message, and then it will generate the final answers based on the qualified paths. And the final one is this, like it will, because in our previous step, it's providing a score against each the paths which are created. Evaluator would give us score for all the proposals. And then in the final one, we are considering the high proposals or the high scoring proposals. And with this search loop, like we are just extracting all the high scoring proposals. It's nothing related to this LLM, but just is extracting the high number of scores for the proposal. And in the last step, where we actually synthesize our output, then again, like we create this user message and system message. So take the optimal path to provide the LLM as explicitly instruction set to generate the final answer and the detailed answer. And system message you can provide. Your task is strictly follow the optimal plan provided by the user, executing each path sequentially to generate the final and complete answer. And over here, the plan, the output from our previous this search function, it gives a high scoring paths to our this synthesis step. And on execution of this LLM, this create chat function, passing the system message, user message, and now you can see like we have this 0.1 as low score because we want the reliable execution based on the high scores. So this is critical part. So now this final function will generate the output of our this entire question, like where we wanted 3 cities, historical visit, and within our budget. So if I run this, so all these functions, all these execution would happen step by step. Proposal would be created. Once the proposals are ready, then evaluator will evaluate those proposals based on the past user message, and then synthesize step would create the detailed itinerary for us. So in the running part, we can see like the depth. So this is the generation of the, let's scroll up. So it's going to the root. First of all, this expanding one state, compiling a short list of 3 historical places, map out their top historical attractions, draft a day by day itinerary. So it's a first path from root. Depth to select the 3 specific cities, and then we are passing that for the optimal plan creation. So now in this step, like where our evaluator is also like giving a score 7999. So based on the highest score, whichever point got this highest score, then that would be considered the final answer for our synthesize method. And then this final generation of our detailed plan would happen. So final generated answer is European historical city, 3 days, 3 cities itinerary. Cities is a brief about like the plan, and then detailed plan is created based on the per day thing. So per day itinerary is created, very detailed one based on our prompts. So you can see like one small question can be interpreted, can be run through like multiple proposal and evaluation steps. So this, all these things, when you interact with ChatGPT, when you call your, okay, give me itinerary, then everything is being done internally. So one user statement or user message, user query is converted into the tree of thoughts, where each path would be considered with the tie-up with the evaluator, which gives the score to it, and then this detailed itinerary is created. So if I go to ChatGPT and I will say, okay, generate a plan for 3 days visit in Italy with budget of 2000 USD. So if I just do this, you will see like the answer, it's generating everything in one shot, but behind the scene with your one question, internally LLM is creating all the proposal or the tree of thoughts to generate this detailed proposal for you. So isn't this beautiful, like where how just one single question is converted into the detailed prompt for your LLM, and then LLM based on that give you the entire detailed plan. So for the complex applications, we generally follow this tree of thoughts so that we have like proper detailed reasoning plus evaluation behind the scenes. So these are few important and famous techniques like which we use for any prompt engineering. And then we have this prompt templates. So this is nothing but like how you define your user message and system message. So when I say like prompt templates, I can just show you the samples, like what I mean by this prompt templates. So prompt template is nothing but like you specify how you specify your questions, your user message and system message. So simple one is like with a Python format, like where you specify your question with curly braces, and that's very variable which you fill out later. So it's a normal way of specifying your user query or your user message or system message. And as you, if you are familiar with Python, then you have this string format, like where you can specify the formatted string and give an example of explanation the topic you can provide. So this is basically like it creates your entire user message with prompt, this prompt template. And the important one, like which I just want to highlight is this Jinja 2 is very much very well known like prompt template, where the variables are specified with a double curly braces, and it's basically used for creating the complex prompts which is having if conditions, for loops, and the any very much dynamic prompts. If we wish to generate, then we use this Jinja template, we import from template library, and then we specify. So over here you need to, if you need to like specify a long template based on if and else condition, then you can use this Jinja template. Then we have this prompt template from LangChain, and then this provides the input variables. So you provide the array of your variables, and then in template you can replace those variables like this. So this is again like pretty much like a very well known way of writing prompts templates. Then we have this again like from LangChain, we have this chat prompt template, where again like we specify how we specify the system message and the user message. One more that is from few short prompt template, where we actually create a array of our examples, input and output, and then in one shot like we provide this, we create a prompt template we provide all the examples in one shot, and input and output are defined like this. So this is how we can create a few shot prompt template with examples. So these are very well known prompt templates way. If you wish, like you can build out your applications using any of this template. So simplest one I showed you, this the format strings, where you can just replace your dynamic values using this format string, or you can just take help of this Jinja or LangChain templates also. So I think like that's pretty much foundational about this prompt engineering. And the next step we are going to take, like to build out any LLM application, we will be talking about LangChain's library, and we'll be talking about RAGs. So RAG is pretty interesting one. So retrieval augmented generation is an architectural pattern that improves the output of our LLMs. So we'll be talking about them in detail. So when I say improve the output, that means like it gives the actual context to your LLM. Because if you ask questions about your own company with any ChatGPT, Gemini, like it will not be having any idea or your company policies or company data, right? Until unless it's not public. So how to make the application that use like pretty much tailored experience with your documents, with your systems, it should able to like answer the questions, answer your queries, like you provide the PDS document related to your organization or your group, then you would be having your customized answers. So that is pretty much can be done with the RAGs, this retrieval augmented generation. So we'll be talking about that into next session. So just stay tuned for that. And thank you for today.